Hello, my dears. In this session, we are going to see probability. So, it is a very simple chapter as you have been learning probability for the past 2 to 3 years. And I have selected all possible questions under probability, giving detailed explanations for each and everything with clear examples. So, the video is going to be a really interesting one. So, please do watch and follow all the concepts carefully. If you have any doubts, I have given my number in the description, so you can contact me anytime. Now let's go into the session. Let's keep it rolling. So welcome to the session. In this session, we are going to see a simple chapter which you guys have been learning from your earlier classes, probability. So no need of any specific introduction to probability because you guys have been learning it earlier. So I have given a detailed notes on everything. This notes will be very useful for you in solving the problems. Now let's go to the session. So probability of any event. So this is the formula: number of favorable outcomes divided by number of possible outcomes, all the possible outcomes, which is represented by using a special term called sample space. So probability of E, where E is the event, so probability of E is the number of favorable outcomes divided by sample space. So now you can see here the important conditions. The probability always lies between 0 to 1. So it should always lie between 0 and 1. It can be 0. If the probability is 0, then it is called an impossible event, and if the probability is 1, then it is called a sure event. Mostly the probability lies between 0 and 1. So probability of sure event, as I said, it is 1. So example I have given: probability of a number to be less than 6 when a die is thrown once. So when a die is thrown once, you have 1, 2, 3, 4, 5, 6. So it can be 6 or it can be less than 6. So the probability of it to be less than or equal to 6 is 1. And the probability of the same scenario, I'll rephrase it in a different way. The probability of a number to be greater than 6 when a die is thrown once. This is impossible because you have only 6 outcomes: 1, 2, 3, 4, 5, 6. So more than 6, for it to get a number, it's impossible. So the probability is 0. So, and next is the probability of a given event is X. Then they'll be asking you to find the probability of the event not happening. So probability of A is X, then they will be asking you to find the probability of A bar, which is A not happening. So that should be 1 minus X, because both of them, A and A bar, both represent complementary events. Complementary means exact opposite. So these are the basics. Next, I have given some useful problem solving things. So here you can see dice when it is thrown once. These are the events. So probability of an odd number 1, 3, 5. So you have 3 favorable outcomes out of 6. So 3 by 6 is 1 by 2. Similarly, probability of prime number 2, 3, 5. So 3 out of 6 again, that is 1 by 2. And probability of an even number 2, 4, 6 again is 3. So 3 by 6 is half. So like this you have to do. And next is when a die, same dice is thrown twice. So these are the different events from 1, 1 till 6, 6. All these events can happen. That is 6 square, which is 36. So you have to write it here, all these events, before solving the question. So probability of sum less than 7. So less than 7 means, if you see, from 1, 1 till 1, 5, all of them will be coming. Similarly 2, 1 to 2, 4, and 3, 1 to 3, 3, and 4, 1, 4, 2, and 5, 1. So if you add everything, you get 15. 15 by 36 is 5 by 12. So similarly, you have to do all these things. Product less than 16, you have to just check it from here, and then you have to write probability of doublet. Doublet means identical numbers on both the things. That is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So you have got 6 doublets. So they are asking doublet of odd numbers. 1, 3, 5 are odd numbers. So 1, 1, 3, 3, and 5, 5. So it will be 3 by 36, which is 1 by 12. Like that you have to do. Probability of sum 8, you have to manually check and then write. I think sum 8 here only 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. So 5 by 36. And sum is 13. No number if you add, you get 13. So it is 0. Impossible event again. And sum is less than or equal to 12. That is 1. All the events, if you add, you get sum as less than or equal to 12. So you get that is 1. Sure event. And similarly, next is coin toss. Coin, if it is tossed once, so you get head or tail. So probability of a head is half, and probability of a tail is also half. And next is if the same coin is tossed twice, instead of once, if it is tossed twice, so I have written the favorable events HH, HT, TH and TT. So exactly one head. Exactly one head means strictly only one head should be there. So there are two events, 2 by 4, half, and exactly one tail. Similarly, there are two events, 2 by 4, half. At least one head. At least means minimum of one head. Minimum means what? There should be one head or more than one. So 1, 2, 3. So it is 3 by 4. At least one tail. There should be minimum of one tail or more than one. So 1, 2, 3, 3 by 4. At most one head. At most means, please understand the difference between at least and at most. At least means minimum and at most means maximum. At most one head means maximum of one head only should be there or no head should be there. So if head is there, then it has to be only one or no heads. So 1, 2, 3. So 3 by 4. At most one tail. Similar logic. Maximum of one tail only should be there or no tail at all. 1, 2, 3. 3 by 4. So that's the difference. So now coin is tossed thrice. You get sample space as 8. So I have given out all the favorable events. So the same way how we did for this scenario, the same way I have explained here, exactly one head 3 by 8, exactly one tail 3 by 8. Like this you can calculate the values and then you can cross verify and cross check. And next is cards. See, many people would be aware of the cards. You guys would have played cards already. So it's though some, but there are some people who might not have played cards. So for that I have just given it in a pictorial way for you guys to understand it in a better easy way. So you have four different uh, sets in cards, like hearts, diamond, both of them will be in red color, clubs and spade, they will be in black color. So A means number 1. So from number 1 till number 13 it will be there. So A means number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And instead of 11 you have jack, instead of 12 you have queen, and instead of 13 you have king. So like this easily you can remember. So all the cases you can write, and then it's very easy now. After once when you write it in this exam, when you write, remember this, and when you write it in your exam, questions can be easily answered. Probability of black queen. Black queen means you have 2 out of 52. So 2 by 52, which is 1 by 26. Neither red nor queen. No red should be there. So only black. So black have 26, but you have two queens in black. So since queen should not be there, you have to subtract 2. So 26 minus 2 is 24 by 52. So you get 6 by 13. Such a simple one. Probability of yes and black. Yes and black. So it is 2 by 52. It is 1 by 26. Black case. That's what they are meaning. So like this, if you see face cards, another important concept which I want to tell here is face cards. Face cards is nothing but jack plus queen plus king. Everything put together. So you can see here you have 12 face cards. Red face cards is 6. Black face cards is 6. So probability of red face card is 6 by 52. Probability of face card is 12 by 52. Out of which red face card is 6 by 52. Black face card is 6 by 52. So like this you have to do the calculations. I hope that it is interesting for you guys. And next is same birthday, different birthday. Like that the questions will be asked. So same birthday means probability of both of them to have the same birthday. So you have only 1 out of 365. And probability of both of them have different birthdays. You subtract it from 1. 1 minus 1 by 365, it will be 364 by 365. Complementary events. So very simple case. And leap year and non-leap year type of questions they'll be asking. I think yeah. So leap year and non-leap year kind of questions they'll be asking. So leap year you have 366 days. Uh, and then you have 52 weeks. So 52 into 7, this is a default calculation. You can ignore this because every day will be coming in this case. Each and every day will be happening at least once here. So you can skip this. So this 2 only is final. So 52 into 7 plus 2, meanwhile you get 366. And 52 into 7 plus 1 you get 365. So here this 2 I have split it into different scenarios. Like for example, Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, and Saturday, Sunday. So they'll be asking probability of any day in a leap year. Say for example, probability of Tuesday appearing in a leap year. You have 2 out of 7. 1, 2, 3, 4, 5, 6, 7. Sample space is 7 and Tuesday appears twice here. So any day for that matter, in fact, appears 2 times out of 7. So probability of any day in a leap year is 2 by 7. Probability of any day is a non-leap year is 1 by 7 because 52 into 7, which we can ignore, plus 1. That 1 is all the days: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So probability of any day in a non-leap year is 1 by 7. So probability of 53 Tuesdays in a leap year. So same way, 53 Tuesdays in a leap year. So I have already explained you Tuesday appear 2 times out of 7. So it is 2 by 7. And similarly 53 Tuesdays in a non-leap year, it is 1 by 7. With this we have completed probability. I hope that this video was useful for you. Good luck to all of you. We will see in the subsequent video.